So maximum power point tracking means we are tracking a point where the power goes maximum and that is transferred to the PV cell using artificial intelligence, because our system modifies itself by a neural network programming which keeps on updating its data, and PID controller based system because P, I and D are the three decisions taken in parallel and accordingly combined decision is taken. That's the title of my project. Basically, what is PV cell? PV cell is a cell which converts photons to electrons, that is a light energy to a voltage or a current, and basically PV structures are made look like this. They are always in arrays. So I don't care when this particular cell goes max or this particular cell goes to the max, but array as a whole, when it goes to the max, at the same time I should put my output of the panel to the battery. So that's why MPPT technique is required. If it was a single plate which generates a voltage above the battery voltage, I could have just connected it whenever that voltage crosses the battery voltage to the battery for its charging. But there is a problem with this, is called overcharging problem. So once your voltage is higher than the required charging level, you should give it a PWM control. PWM is just switching on and off the particular supply being connected to the battery, and a battery will act as a load in this MPPT technique. Next is what is MPPT? So this is basically typical IV characteristic look like, and if I multiply V with I will get a increasing power till MPPT, and then the power will goes on decreasing. So it's like a peaking function, and this peak arises at whatever point is called maximum power point, and whatever voltage at that point is called V MPP, and current at that point is called A. It could have been I MPP also, and this is the power. So generally current, voltage and power is the graph, and this is how your panel voltage versus current look like. Means for 1 volt, 2 volt up to 19 volt the panel is not loaded, so current can be provided, constant current source, and then it gets loaded, so current goes down above a higher voltage. So this particular point should be achieved for this is the overall panel characteristics. So at this point if I switch, the maximum power will be transferred from the panel to the battery, and that is what we are trying to achieve. Now how this happens in existing technique? So we have a solar panel whose current and voltage are monitored by a manual voltmeter and current meter. MPPT controller they are using. It's just a decision maker like a simple SCADA or PLC system, and the converted values are given through a DAC or PWM control to a DC to DC converter, which could be a chopper, and that power is delivered to the load. So this is a simple system where MPPT point is pre-faded in the controller, and we just monitor when this I and V reaches that point. At that time we'll start this converter and power is delivered to the load, and load in this case is battery. Now I guess I have gone back to the same slide. So this is the next slide. Here we are explaining how relay can be used in switching a PV to a battery, and we are using a Darlington pair. This is ULN 2003 Darlington pair, which has a base signal. This could be 0 or 1 coming at the pin 1B. There are 7 Darlington pairs in each ULN, that is ULN 2003. Gain of this is beta into beta, that is beta square, and whatever you apply at pin 1B, its corresponding output is going to come at pin 1C. तो यहाँ पे जब आप लॉजिक 1 अप्लाई करते हो तो यहाँ पे लॉजिक 0 आता है, और यहाँ लॉजिक 0 अप्लाई करते हो तो यहाँ लॉजिक 1 आता है. So here the Darlington pair is just working as a beta square amplifier, and this common is generally pulled up to VCC. So by default the relay is in off condition because यहाँ भी VCC होता है और यहाँ भी VCC होता है. Whenever a signal applied at this base, the transistor get fired inside the ULN, and that's why your relay gets activated, and then we'll pause the video